Let me share my screen. So we'll start with the basic introduction of Teradata. So in this module, we'll discuss what is Teradata, why we need to use the Teradata, and what are the different versions that we have, and which version we are going to, deal with. These details we'll discuss. So, like you guys know, what is data and database, data warehouse. I'll just brief you on that. We'll start with what is the data and all those. So whatever the raw information that we have, raw data basically. Data is nothing but details, right? So when we store it in the in the form of tables, and we store it in a small small set of data, we call it as a database. The reason is that a database can hold data which is maybe the limit is very limited. The data whatever we have, the volume is very small. So usually in the OLTP, the online transactions, whatever the transaction it happens, like withdrawing the amount from the ATM, or maybe playing a call, placing a call on the mobile, or maybe it is a paying your mobile bills, any utility bills, something like that. So everything is a online transaction. It's basically a transaction, which is a small, very tactical in the sense it runs highly tuned queries, and it is a 1 or 2 seconds, or maybe even in the less than 1 second, fraction of seconds, the transaction duration will be. So these are small in size. The database is very small, which holds the different data type, which different type of data about the user, the transaction. It can be, if we deal with the banking sector, then it could be something like an account, customer ID, account and his details, maybe loans, or maybe fixed deposits, anything. So anything related to his account, we only deal with individual transactions. When it comes to the analytical data warehouse, we deal with the organizations, we deal with the firms. Something like in database, the online transaction, the transaction whatever it happens, that is between maybe targeted audience or individual users, customers. When it comes to the analytical, it is between the banks, regions, data marts. So whatever the data we have in the transaction, online transaction, that happens in a fraction of second, and it is ongoing process. Every day-to-day activities, or maybe one-time activity, whatever it is. But it is very small and simple. To analyze this data, whatever the transactions it happened, we just move the data from the transactions, whatever the transactional data, to the analytical data. That is OLAP, Analytical Processing. So here, whatever the target that we have, that is data warehouse, where we maintain the databases. And the data warehouse will have the data, and the databases basically. Internally, you create different tables. Again, the database and data warehouse both are basically relational management, database management, because we deal this data and database and data warehouse, data marts, whatever we say. All these are depending on the size of the database, or size of the tables, or maybe size of transactions, number of transactions. It all depends on that. We define this is a database, this is data warehouse. But for the system, it can be a database, it may be a data warehouse, but internally, whatever the data, the logical data modeling, whatever we do, like tables in the form of rows and columns, we maintain the same data, and the form, the translation, the transformation, everything is different. That is only the case. Otherwise, the data will be the same. So when we talk about the data, Teradata is basically a data warehouse where you see different tables, RDBMS, relational database management, and it follows all the database concepts, whatever we have, DBMS concepts we say. So chord rules, everything will be implemented, and it works basically on the DBMS concepts. But the only difference is data warehouse, the retention data, whatever the latest data that you see is different. It's not online, it's not on the fly. Operational data, online transaction. Analytical data, data warehouse. So this is the difference. We maintain the data in the form of tables, rows and columns, and the combination of the row and a column is called a data, whatever the data we have, data value. And here Teradata is basically a data warehouse which follows the RDBMS concepts. All the RDBMS, it also follows the ANSI SQL structured query language to deal with the data. The data and Teradata database is an open system. Open system. It's not open source. It's an open system, which means if it is an open source, you can take the source code. You can change whatever the changes you want. You can, derive whatever the functionality you want. You can implement it. But Teradata, they don't allow us to expose to the data, whatever the software, the source code. This is a open source. An open source means you can install on any of the platform. Platform in the sense it can be a Unix platform, it can be a Windows platform, or it can be any other operating system, which can store, which can manipulate the data warehouse. So this is a open system. We have there are multiple versions that we have, ranging from TDD v2r1 to the latest is 15.10. There are many Teradata versions released, around more than 10 versions are released. But out of these, till 13.0, the data warehouse, whatever we have, the versions, Teradata version, it was installed along with the Unix, whatever the Red Hat Linux and SUSE Linux, along with them Windows, along with them they used to install it on the MPRAS Unix system. MPRAS is the Unix flavor which is built specially for the Teradata software and which is designed by Teradata. So since Unix is an open source, so they can change anytime. You can take the source code, you can make changes, and you can get the patent. So the same thing happened here. It was till 13.0, version 13.0, the Teradata was maintained on Windows as well as Unix, Red Hat Linux, and also MPRAS. But from 13.10 onwards, they stopped using this MPRAS. They have a tie-up with the SUSE. So whatever the new version that comes out from Teradata, they completely dependent on the SUSE Linux as well, the operating system. Now everything is SUSE /10, /11. These are the versions that we usually come across from the operating system perspective. When it comes to the hardware level, Teradata, they have their own design for even for Teradata, the hardware wise. So the hardware is something like, it comes from the Intel. They provide this, all the detail, all the designs, and they develop the things, the processor, everything. Node is completely different architecture. There you see multiple hardware components, multiple software components, which protects the data and which can help you to run the query in a quicker way. Like execution will be very fast. Parallelism is implemented in Teradata, both in hardware level as well as software level. So how and why, that we will see in detail. And Teradata database is large database that serves or accommodates multiple clients. You can have multiple clients. It can be centralized Teradata server, whatever the node you purchase, it acts as a server, it acts as a client. It works in both ways. At the same time, it can accommodate any huge number of clients. People connect from their laptops and desktops, LAN connection. You can connect from any reporting tools. You can connect from any ETL tools. You can also connect from any mainframe systems. So anything that can directly connect to the Teradata, and they can manipulate, they can execute the queries, and they can get the responses. So ETL process, both ETL and ELT, both the process will be, you know, Teradata supports. So we'll see the difference why ETL and when it is ELT. We'll see. Okay. So what is Teradata? So Teradata is basically a data warehouse, like I said, right? And here various client platforms access the Teradata, and that is completely purely dependent on the TCP/IP protocols. But the TCP/IP protocol, whatever we have traditional connecting tools, connections, the same thing is implemented here with a different naming conventions and different naming. You know, the data parcel length and everything will be different. The reason is that Teradata is a open platform. You can install it on any of the softwares, operating systems. You can install it on the Unix box. You can install it on Windows. You can install it on mainframes like IBM servers, uh, like AX. So these kind of software also you can install. HP software operating system also you can install. So it's an open platform. When it is the case, whatever the connection, whatever the request that comes from the different platforms, something like a request, I connect from my Windows system, my laptop. Some people connect from the Unix system. Some request comes from the mainframes. So in all these cases, whatever the incoming, the request that is from a different platform, different operating system, we need to understand. Teradata supposed to understand the operating system calls as well as the Teradata calls. Something like SQL function, maybe you may use a in the middle, like you install some UDFs. You created one UDF. So UDF is a user-defined function which is, acts with runs on both database side as well as the operating system side, right? The reason is that, suppose let's say the UDF is designed on the Java. Maybe some source code is based on C language. So suppose if it is the Java UDF, then Teradata should understand the Java, but it doesn't know Java. So who has to compile that software? Who has to compile the source code of the UDF? So that is handled in the operating system level. Java compiler, where Java compiler is installed, so that computes the, or maybe translates, interprets the Java source code, and it, whatever the output that comes from the source, so that will be given as an input to the Teradata SQL. So here we need to handle both operating system calls as well as the Teradata calls. So from my system, it may be Windows. So Windows, I connect using my Windows system, and I call a UDF, user defined function. So that will, it may be involved C language, C source code. So it has to be translated, and then Teradata can understand that. So for that purpose, the TCP/IP, whatever the connection, that is rebuilt, redesigned into CLI, call level interface. So that is what through Teradata connects and it executes. And the other thing is that Teradata, it purely supports the ANSI SQL, whatever the structure query language that we have, ANSI SQL, everything, the syntax, the functions, everything, whatever we have, everything will be supported. You can directly use in Teradata. If you are comfortable with SQL, Teradata, ANSI SQL, it is very easy to migrate. because most of all the DDL, DML, data definition language, data manipulation, data transactional control, data retrieval, whatever we see, everything is compatible with Teradata. You can write the same syntax that you write it for the select query. You may join multiple tables using inner join, left join, right join. Still that works in Teradata. You may write some update statement. You can write an update, some kind of merge function you can write, merge concept you can do, or it can be something like any transaction control, something like access rights provoking, providing and revoking the access rights, that also you can do. The same syntax, everything can be used here. Even whatever the RDBMS concepts, something like database creation, user creation, or it can be, any rollback, roll forward concepts. Most of the things are from RDBMS perspective, even that works with the Teradata. The SQL wise, ANSI SQL is the concept which completely works. Along with that, we have few functions which comes from the Oracle or maybe different platforms, maybe like LTrim, RTrim, or replace, these kind of functions, replace functions. They are not designed in Teradata. They are basically UDFs, user defined functions. So those they created in Teradata as a fast path UDFs, fast path in the sense you don't need to take the source code and install. They come from the, they are built in, they come from along with the Teradata versions. So you can also make use of that. Along with that, we have some analytical functions, OLAP functions that you may come across in SQL as well. Apart from that, like rank, qualify, quantify. So along with that, Teradata has their own functions. So it provides more flexibility. Coding wise, it is very flexible. It has given some shortcuts, something like if I want to write a select query, I start with select, SELECT. Instead of select, you write everything. You can in Teradata, you can simply write SEL. That Teradata can understand. So few coding flexibilities are given from Teradata SQL. Along with this, whatever the stored procedures we have, whatever the cursors, triggers, whatever you define in SQL, so the same thing you can make use of. But SQL, when it comes to the stored procedure, it's a programming language, so that is not an ANSI SQL, right? It's a multi-statement request, so the syntax will be different comparing to the other. Like PLSQL is Teradata, Oracle's own. Similarly, TSQL is come from SQL Server. Similar to that, stored procedure, Teradata stored procedure, little bit different. The functionality is same, but the way you write the query, the way you define the stored procedure, that is different. Syntax is different. And here the main purpose of Teradata is maintenance, ability to manage large amounts of data. In OLTP, in any operational data, if you come across, the data's volume will be ranging from 100 GB to maximum of 10 terabytes. That may be, if it is a widely used and there are many applications, application wise you see different databases, but usually it will be 1 terabyte or 2 terabytes of data. But when it comes to Teradata, it ranges from terabytes to the petabytes. So you come across sometimes, if you are working for a banking domain, financials, then definitely you come across around 1 petabyte or more than that, 1000 TB, 1500 TB size of data you come across. And table size, if you are maintaining for 5 years or 8 years, the retention depending on, usually in RDB, in Teradata, the data warehouse, not Teradata, in data warehouse, you come across the retention would be minimum of 3 years, maximum will be at least 7 to 8 years they maintain. And whatever the rest of the data they maintain in the tapes, they don't maintain it on the production system. So so you come across at least 5 to 8 years of data. So that will be very huge. The table size would be somewhere at 50 terabytes, 20 terabytes, 13 terabytes. So that kind of size of the table. Even even after the compression is implemented. There are different compression techniques. We'll discuss that as well. So after compressing the tables, you can see somewhere at 20 terabytes or 30 terabytes. Otherwise, it will be somewhere at 100 terabytes, something like that. So the size will be high. The large volumes of data Teradata can handle. But how quickly you can retrieve the data, how quickly you can load the data, that is very important. When you are dealing with the data warehouse, the only thing is that cost is dependent on 4 parameters. It will be identified on 4 parameters. CPU utilization, when it comes to the physical resources, how much CPU you need, what is the processing capacity that you need. The second one is the memory, RAM wise, how much RAM you need. Third one is the number of IO operations, how many IO operations I have to perform in a second. So response and throughput times. The fourth one is the execution time, how long we execute the query, how quickly you can get the response. So these are the 4 parameters that is purely dependent on, and we identify the performance of the system or maybe query depending on these 4. So in Teradata, you may submit a small query which doesn't require, there are no conditions, nothing is there. Simply select star from a table. This is a simple query for us, but table may be 10 terabytes. There are billions of records. How many records you are fetching? That is important. Second thing, maybe there are 2 billion records in the table and you want to identify one particular record. So you have a where condition. How quickly you can retrieve, because when there is a condition, something like where clause, it has to go through every record. 2 billion records, it has to read every record line by line. Then it has to identify what is the value, whether this record is qualifying with this where condition or not. Then it picks up the data and it gives it to you. So how quickly you can filter the data, how quickly you can get the response. This is very important. So Teradata works best in that. The reason is that it has a parallelism. Very first thing is it has the parallelism. The indexes, whatever they define, they design, they work in a gunshot manner. So they directly go and pick up the data. But it all depends on, again, physical data modeling. How efficiently the developer has created the table. How efficiently you have chosen the index columns. So it all depends. Once you define, once you design, or maybe you identified the candidates, then that is forever. You don't need to change every time. No maintenance is required. Suppose let's say when you created a table, the source, the data that you have is somewhere at 100, maybe 100 records, or maybe 1000 records, or maybe few hundreds, 100,000. But when it comes to long run, so maybe after quarter, or maybe 6 months later, 6 months later, the data is increased and the table size is somewhere at it reached 2 billion, 3 billion, billions of records are inserted into. In that case, if it is an other RDBMS, then you have to maintain indexes, you have to reorganize, everything has to be done. But here, this is not required. So the repository, whatever we have in Teradata, that acts system, it takes the response and it organizes the system, index and everything. Of course, we'll see in detail, but this is why and what is Teradata, we are just looking at. And the next slide, this slide explains what are the different versions we have and what are the major versions and in which version we are going to handle. So we'll see. So the Teradata version started with V2R1, but V2R1, R2, R3, R4, they were not released for the end user. They are all beta versions. They were not released for the end users. So the official release was V2R5. This is the first version that is given to the end users. So people started working on V2R5. Later they come up with V2R6. In a short span, not even less than 6 months, they come up with V2R6, and that was that it was there for few months again. immediately they come up in a short span, something like in a year. Both V2R6 and TD12 were released. TD12 is the major version. It has come up with many advantages, many features. Those were not there in V2R5. Many bugs were cleared, because that time when V2R5 was released, it was active data warehouse. Active in the sense you may hardly see the latest data would be somewhere at the 3 months old. When it comes to TD12, it was came down to somewhere at 24 hours of difference. The gap would be the latest data that you come across is 24 hours to a week. So 7 days to 24 hours. That is the latest data that you can see in data warehouse. From to TD12, so since the replication, everything is happening on a faster way. So they identified many bugs and all those. They released them, they cleared them, they developed new features and functionalities, because the data is increasing, the functionality is increasing, number of operations are increasing. From data warehouse to active data warehouse, active to the enterprise data warehouse as came up. So now everything is enterprise data warehouse. You hardly see the gap between OLTP and OLAP. The transaction, the moment the transaction completed on the online transaction completed, the data is coming into the analytical. So it is coming to the data warehouse. You hardly see 6 to 8 hours or maybe business hours difference, like 6 to 8 hours of gap only, because now it is globalized. The markets, whatever the customers they have, whatever the markets they have, they are designed with they have come up with the individual data marts, regional data marts. Something like, suppose let's say we go with any American bank, let's say American Express. So they have branches everywhere across the globe, right? Similarly, you can go with any big thing, something like eBay. It is worldwide. Almost every country they are using this e-commerce, this site, right? So if it comes to the US region, they maintain one data mart. For Middle East, they maintain another data mart, and for Asia Pacific, they maintain some other data mart. But these are all regional data marts. At the end of the day, the data pushed from these regional marts to the centralized data mart. So if the data is maintained in the same system, but whatever the data that is generated in the individual regional marts, so that comes to the data warehouse. So suppose let's say in US, whatever the data that is that has generated during their business day, that will be pushed to the data warehouse during their off hours. So you hardly see 6 to 8 hours of gap between the OLAP and OLTP. The same thing happens with any other region. So that's why there were many bugs and issues. So most of the things were resolved. At the same time, they have come up with new things, new features, which can give you more enhancement. Like you can quickly retrieve the data, you can quickly load the data, that kind of stuff. ETL and ELT process has enhanced. So TD12, 13, 1310, 14, 1410, 15.0 also completed. Now 15.10 has come out. Now people, they just started exploring 15.0 and 15.10, of course, but in the market you see 15.10. We deal with the 14.10. The reason is that 95% of the customers are right now on 14.10. So we'll handle with 14.10 and we'll see in detail. There are many versions, like many features in 14.10. We'll see in detail. So this is the overview. What is parallelism and all those. Parallelism, when we talk about the parallelism, it's a shared nothing architecture. It won't share it. There is no workload. Balancing will be there, but workload sharing is not happening. If the task is given to me, one task is given to me, at the same time one task is given to you. So if I complete it quickly, I don't share your workload. Similarly, if you complete quickly, you don't share my workload. That is the concept, shared nothing architecture. Otherwise, whatever the physical resources, whatever the logical resources, everything will be shared. So shared architecture with a shared nothing parallelism. Parallelism is based on the shared nothing architecture. But whatever the physical resources, CPU, like hardware and software components, whatever we have, so that will be shared among the resources. So that we'll see in detail. So what are the advantages? When it comes to the advantages, first thing is unlimited scalability. Suppose today I started with my business and I started practicing the Teradata. Teradata, I am into just entered into Teradata. Now my data, whatever the data that I have is very limited. Maybe few, suppose let's say 100 GB. But my forecast is down the lane in 6 to 8 months, I would get somewhere at some 100 terabytes of data I'm going to get, because it's a migration. Maybe I'm centralizing. I'm getting my business is coming from it is spread across the globe. So different source files comes in and we load the data. So now I think that okay, for today, maybe for the next 6 months or 6 months to 1 year, whatever the hardware that I purchase, that is sufficient, good enough. So I purchased that. But after a year, I realized that this is not sufficient. I need to have more performance. I need to expand my system. So in that case, I don't need to decommission whatever the existing one. I don't need to take the backup and restore. Those things are not happening. You just purchase a new one, new box, and just connect to this one. So it is something like you connect a USB mouse to a laptop. Simple, plug and play. The only thing is we have to reorganize the data, so that again you don't need to do individuals. We don't need to do all these reorganizing the data. With a single command, the data will be distributed across the new systems and the old systems. So the load balancing will happen. It starts with that. So hardly you see some, depending on the size of the volume that you have, the database size, data warehouse size. So if it is a small data warehouse, probably in 2 to 3 years you can close it. But if it is something like big 1 petabyte, 2 petabytes, it may take a day, but it may be in 24 to 28 hours everything will be closed. So that is scalability. The next one is the parallelism. So why parallelism? We'll see in detail. It's basically based on the shared nothing architecture. They don't, whatever the data, whatever the task given, so they don't share that. Load wise, they don't share anything, but resource wise they share. So you see the parallelism at hardware level. They maintain two, for every component, they maintain two components. Something like if it is a UPS that is required, right? There will be 2 UPSs. It is when both are online, they run in parallel. They don't share anything. If one is down, then other will work as a fault tolerance. But otherwise, both will be running and they don't share anything. Load balancing will happen, but data sharing will not happen. Shared nothing with respect to the workload. Optimizer is the first thing on high priority, and rank wise it will be on top. The reason is that optimizer, it identifies the whatever the query you write, whatever the query you submit. So it rewrites the query internally and it comes up with the best execution plan. There may be multiple paths to read the data from the disk, but which is the shortest path? Again, it depends on the 4 parameters: CPU, IO, spool the memory utilization, and the fourth one is the execution time. So in all the 4 cases, we have to bring it down. Cost, CPU wise, we have to use low CPU cycles, and if it comes to the memory, we have to use very limited CPU memory. Execution wise, how quickly you can as quickly as possible. We have to do that. So optimizer will come up with that kind of execution, the plan, and it implements that. But we need to provide few inputs to that. Of course, we have to give. So those we'll see in detail. But any kind of a query, complex query, any number of join operations, any kind of process you have, like stored procedure. So everything is identified. Everything will be decomposed into multiple chunks, multiple steps, individual steps by the optimizer, and it comes with the best execution plan. The next one is data modeling. So model the business is, it's again depends. Usually Teradata, initially it was designed for third normal form. Of course, even that time also it was meant supporting all the data modeling. Now whatever the data modeling you come across in the data warehouse market, you can implement it in Teradata. Like star schema, you can go hybrid model, you can go you can say anything. SD, slowly changing dimensions, SDCs you can implement. Anything you can do that. All right. So data modeling wise, star schema, anything you can implement. Facts you can create, dimension tables you can create, anything, whatever the data modeling you say. So everything can be implemented. Lowest cost, when it comes to the maintenance activities, once you purchase the box, there are very less thing that you have to, the cost wise, you don't need to spend much on that. Availability, yes, it is high available, 100%, almost 100% available, and 100% system is ready to serve you. So, but there are few occasions where there may be a hardware failure and software failures. So in that case, how the tolerance, fault tolerance, as well as the standby, how they are maintaining, so that we'll see in detail. But data protection, data security, data availability, this is on the high level. And it works in whatever the size of the data. You may have one record in the table or maybe 1 billion records in the table. It acts in the same manner. It identifies the same execution plan and it goes with the same. Performance wise, it's on top. It can connect, like I said in the first slide itself, there are multiple clients. People connect from network attached, something like laptops and desktops. Some people connect from mainframes. Some people connect from the different clients. Something like people connect from Unix platform. People connect from Windows platform. It's an open platform. At the same time, it handles both ETL reporting tools or maybe individual client tools. Anything can connect to the system. They can run. Industry standard ANSI SQL is supported. Manageable growth via modularity. The data is growing. You can just, if you need, you can add the extra disk arrays. Simple. Fault tolerance at all levels of hardware and software. This is where you see 100% available system availability. Data integrity and reliability. So whatever the data, there won't be any data corruption. Something like, the simplest thing is that suppose we both work on the same application and I insert some data into the table, at the same time you try to update the table. If both are allowed to at the same time, there will be data corruption. At the same time, suppose another guy is trying to generate a report, then there will be data inaccuracy, right? So in such cases, how the system will handle. So Teradata, in that case, it is at the best. So data integrity and reliability is on high. It won't allow individuals to do anything on the table or maybe object at the same time. So there are some states, some queue will be there every time. So we'll see in detail on that. And advantages for DBA, there are many. You don't need to reorganize the data, first thing. Like when you are doing if you are doing any ETL process, You don't need to do a prepare. You don't need to prepare the data. You don't need to sort the data. You need to convert. You don't need to convert the data. Splitting the data into multiple chunks. So that is also not required. Queries run in parallel. You don't need to say like this query has to be run in parallel. This query has to be run in sequence. Teradata identifies that. It identifies the optimizer, whatever we have, it comes up with the parallel steps. And while loading the data, reloading, or maybe data loading, database size, how? So data, whatever the capacity that I have, database size, it can grow till then. There is no cap on the table size. It can grow till the database can accommodate. So there is no space issues. Design, implement, and support partition schemas. No need of table partitions. No need of maintenance. Nothing. Even when you create an index, you don't need to maintain the index. You don't need to reorganize the index. Right. Run programs to split the input data into partitions for loading. Like programs to split the input data into partitions for loading. You don't need to split the data. Like suppose let's say I have 2 billion records, 2 billion records in a flat file. I don't need to split that into multiple chunks to load the data. I can use a type shot. All the 2 billion records can be loaded into the table. So that flexibility is given to the DBS as well as the developers. And this is that on a high level. Teradata is a centralized system data warehouse where multiple users, operational data that comes and connect to the Teradata, and access tools, something like reporting tools can connect Cognos, anything. Nowadays Tableau, ClickView are widely used, right? You can connect there. And similarly, the end users, like I can connect from the laptop, I can connect from the desktop, I can connect from mainframes directly to the database, data warehouse, and I can retrieve the data. Okay, so this is basic introduction. So here I want to say two things. One is the ETL and ELT. What is the difference? Teradata handles both ETL as well as the ELT. So where we exactly use this ETL process, and where I think most of the guys know that, but I just want to say. So when we say ETL, extract, transform, load. So you extract the data, you transform the data, whatever you have outside the database, then you load the data. This is one process. Other process is you don't have enough space to handle that, to translate. So what we do, we extract the data, we load the data. Once the data comes into the database or data warehouse, then we translate the data. So this is the difference. And ETL is for the small data where you can, you have enough space outside the database. Something like you can use Informatica. In Informatica, you cannot use terabytes of data you cannot translate on the system, because the size of the whatever the memory that we have, that is limited. It's not, if you have 1 TB table, then you cannot do that, right? So there is a limit. You can do that. So ETL can be supported. But when it comes to huge data, 1 terabyte is there, I cannot do a transformation outside the database. So at the same time, I cannot place, there is no landing space for the translated data. To do the transformations, or maybe to do the transformation, I don't have any landing space. So what I can do, I just load the data using a stream, like read and write at the same time. So we read the data, extract the data, we load the data. That's it. No landing space is required. So in such case, we go with the ELT process. So whatever the load utility is that we have in Teradata, when it comes to fast export, fast load, multi-load, so these are something that uses in ETL process. Already files are there, or maybe there is some landing space where you can create an extract file and you load. But they have come up with a TPT, Teradata Parallel Transporter. So this is where ELT has come. So it extracts the data, it loads the data, then it starts transferring. Okay, you don't need a landing space. You don't need a landing intermediate servers to load the data from OLTP to OLTP. And there are some application tools and all those. In any case, if the data volume is huge, then you directly load the data using a stream. So this way it works. Any questions on this introduction?
Hi, this is Samir. What are the different topics that are covered as part of this course?
Yeah, Samir, I think you missed the demo, I believe, I don't know. So
Right,
we
I
covered,
did. Yeah.
okay. You can go through the demo. I'll brief you on the high level. So we covered
Mhm.
both development and